How will humanity colonize the solar system? The ambition of colonizing the solar system is becoming more and more realistic as humanity approaches the dawn of a new age in space exploration. In order to establish successful colonies on the Moon, Mars, and beyond, this trip will take a diverse approach that makes use of resources, creative engineering, and sustainable practices. Here are 7 key strategies that outline how humanity might achieve this ambitious vision. Number 7. Establishing bases on the Moon. As humanity's first space colony, the Moon is in a unique position to serve as a vital starting point for further exploration. Since it is just 384,400 kilometers from Earth, it can be reached rather quickly, allowing supplies, personnel, and equipment to be sent there with little delay. Resources abound on the lunar surface, especially water ice found in craters at the poles that are constantly shaded. This ice is revolutionary because it can be electrolyzed to separate it into hydrogen and oxygen and then extracted and cleaned for drinking water. By using hydrogen as rocket fuel, it will be possible to send people to Mars and beyond without having to carry all of their supplies from Earth. By using processes like 3D printing or sintering, lunar regolith, which is made up of stony material and fine dust, can be used to build dwellings that offer defense against radiation and micrometeorite strikes. Ideas that would allow for flexibility and extension when more settlers arrive, such modular designs or inflatable dwellings, are being investigated. Furthermore, the Moon offers special chances for carrying out research and building bigger structures that would be unfeasible on Earth because to its low gravity, which is around 1/6 that of Earth. In addition to improving our knowledge of the Moon, the establishment of research facilities devoted to lunar biology, astronomy, and geology will act as a test site for technology that may be employed on Mars and other celestial worlds. Number 6. Developing Mars as a second home. Mars is frequently seen as the most promising planet for human habitation because of its similarities to Earth and capacity to support life. Mars provides a familiar climate that might make human adaptation easier because of its axial tilt, which causes seasonal cycles and a day duration of about 24.6 hours. It is essential that water ice be present at the poles and perhaps below. ICE-RU technology can extract and use this water for agriculture, drinking, and potentially for fuel by converting it into hydrogen and oxygen. In order to provide breathable air for occupants, advanced technologies are being developed to build dwellings that can endure Mars's thin atmosphere, which is composed of roughly 95% carbon dioxide. In order to defend against cosmic radiation, these homes may have elements like radiation shielding made of regolith or Martian soil. Number 5. Utilizing asteroids for resources. Given the abundance of resources in our solar system, asteroid mining is set to become a key component of humanity's space resource acquisition plan. Metals like nickel, cobalt, platinum group metals, and rare earth elements which are necessary for cutting-edge technologies on Earth and in space applications are abundant in many asteroids. Robotic expeditions will first select appropriate asteroids based on their accessibility and composition in order to set up mining operations. Techniques like autonomous drones or robotic arms could be used to gather minerals efficiently and with little harm to the environment. On asteroids, water can be collected as ice or hydrated minerals and chemically transformed into hydrogen and oxygen for use in rocket fuel or life support systems. Number 4. Building floating colonies on Venus. Venus's harsh surface conditions, temperatures surpassing 460 degrees Celsius and crushing atmospheric pressure make it frequently regarded as uninhabitable. Yet its upper atmosphere offers a special chance for human habitation. Conditions significantly improve at elevations of about 50 kilometers above the ground. Temperatures drop to about 20 to 30 degrees Celsius. The air pressure is comparable to that at Earth's sea level, and there is plenty of sunlight. It would be possible to create floating colonies with buoyant materials that could endure sulfuric acid clouds and still support human existence in a stable environment. In order to power life support systems that effectively recycle air and water, these colonies would need to harness the plentiful sunshine that is accessible at these altitudes. Materials science research will be essential to creating buildings that can withstand Venus's hostile atmosphere, while also offering occupants safety and comfort. Number 3. Developing closed ecological systems. In order to maintain human life in off-Earth colonies, closed ecological systems will be essential for establishing self-sufficient habitats that efficiently recycle resources over long periods of time without the need for resupply from Earth. By incorporating biological processes that transform waste back into useful resources, these systems seek to replicate Earth's ecosystems, thereby establishing a miniature version of Earth in homes on the Moon or Mars. For example, organic waste products from plants and humans can be processed in bioreactors to provide nutrients. At the same time, photosynthesis from plants or algae grown in these systems can produce oxygen. Aquaponics, a system that combines hydroponic plant growth with aquaculture fish farming, might offer a sustainable food source and effectively recycle water in the environment. Plants filter water for fish tanks, while fish waste supplies nutrients for plants. To sustain these closed systems for long periods of time without replenishment from Earth. Number 2. Leveraging solar energy. Due to its abundance and accessibility in space environments where sunlight is abundant throughout the year, especially on the Moon where there are no atmospheric obstructions or weather patterns that affect solar collection efficiency, solar energy is anticipated to become the main power source for all off-Earth colonies. In order to produce power for life support systems, housing construction, industrial operations, scientific research, and even propulsion systems for spacecraft moving between celestial planets, solar panels can be placed on the Moon or the plains of Mars. Advanced photovoltaic materials that are optimized for performance under a variety of conditions could be used to develop large-scale solar farms. Innovations in energy storage technologies will be crucial to ensuring dependability during dark periods, such as the 2-week-long lunar nights or the dust storms on Mars that could block sunlight for weeks at a time. Additionally, improvements in solar panel efficiency will improve the system's capacity to capture energy while lowering the costs of producing them off-world. Research into nuclear fusion and other alternative energy sources could also support solar power initiatives by offering reliable energy production, regardless of environmental conditions. Number 1. Creating interplanetary transportation networks. Successful colonization efforts throughout the solar system depend on the establishment of an effective interplanetary transportation network, which entails creating cutting-edge spacecraft that can regularly travel between Earth, the Moon, Mars, asteroids, and possibly other celestial bodies, while reducing the time and expense of interplanetary missions through innovations like reusable rocket technologies like SpaceX's Starship. These spacecraft must have sophisticated propulsion systems that can travel faster than the current chemical rockets. Ideas like nuclear thermal propulsion or ion propulsion present viable substitutes that could drastically cut transit times in comparison to the traditional techniques currently in use, which usually take several months. Strategically placed refueling stations on asteroids or moons would allow spacecraft to refuel before starting longer deep space missions or returning home after exploration efforts. This would greatly reduce reliance on Earth-based resources and facilitate trade between colonies established throughout our solar system over time through regular cargo transport routes similar to shipping lanes used here on Earth. These specific points provide a thorough picture of how mankind might go about colonizing the solar system using cutting-edge technologies, environmentally friendly methods, and calculated planning to guarantee long-term life outside of Earth. If you liked our video, please hit the like button and subscribe to our YouTube channel.